I used to get a lot more comments about this clamp when it was more visible. I stopped making it as visible and put it up on the track for my gantry crane up there out of the way. So I haven't been getting that many people asking me what it is or asking me if I have a video showing how I built it. I built this, I think I built this nearly 3 years ago. It was basically a mock-up type experiment for a quick grip clamp, very similar to the ones that you get, you know, the usual quick grip ones. Very similar to that. Actually, I modeled it off of that, but I made it entirely from wood. There are no metal parts, and that is its major downfall. It actually works, but it won't put enough force. It's a little bit stiff here because it's all swollen up, I think. It won't put enough force on because of the wooden bar here. First of all, the bar flexes and it dents in a little bit too easily when you put the pressure on with this plate right here. When you're squeezing the quick grip clamp, you're actually pushing this plate backwards, so it pushes this whole thing forwards. And then this one up here just locks it in place. And in doing so, that puts a lot of force right on the bar right there to dent it in. It really needs to have a metal bar to work properly, and it would also have to have metal plates. So I've been thinking about making a new one. And I think that this is actually a pretty good size for it. The rest of the parts seem to work okay. Like I say, it's a little bit sticky right now because it was up there and it's gotten swollen up or whatever, or gummed up with sawdust. The wooden spring that's here doesn't return this as forcefully as I would like it to do. I could make those parts thicker and that would work like that. The one on the front here seems to be stiff enough to hold it in place because I can put a lot of force on it like this and it won't come back. So metal bar and metal plates would really make a big improvement to this thing right here. And I think that sometime in the new year anyway, I may take another shot at making one. After I cut the test sample on the dovetail jig, I left the blade on the saw, tilted at that 10-degree angle, and I made this little simple gadget here, which is just a scrap piece of wood, 3/4 of an inch thick, and I screwed on one of these diamond sticks. This is a fine one, I think it is. I can't see the writing on it because it's screwed down. And the way this works is I'm just holding the blade at the correct angle, and then I'm swiping this across the top to grind down the top of the tooth. And all I'm doing is lining up the tooth that's ahead here with a certain point on my zero clearance insert, which is no longer zero clearance because it's all worn out. But I can accurately line that up, or as accurately as this needs to be done. And what this does is first of all, it evens out the teeth so that they're all exactly the same length or distance from the center of the blade. Also, it sharpens them because this does a much better job of actually sharpening the tooth than that belt does because of the bump on it, which continues to be a problem. I actually threw that belt away after I was done. I also took a marker and I marked the top of the tooth so I'll be able to see exactly where I'm grinding. It is a little bit tedious and it does make a noise that's less than pleasant, but it gets the job done. And I've only got 24 teeth on this blade to do, so it's not that big of a deal. Okay, I finished with the blade. Now I've got the jig set up to run another sample. I looked online and I found this very neat template generator that produces this one right here. That it's fully customizable. You can set the width of the wood that you're going to use, the width of the fingers that you're going to cut, also the angle you want. These are 1 6, which matches the 10 degrees more or less exactly, as exact as it needs to be anyway for this template to work properly anyway. So I'm going to take that and I'm going to stick it onto the deck of my jig, and I'll get going on the cut. Okay, a little dusty, but turned out well. There's a little bit that wasn't cut, but no problem. Clean that up with a chisel. All looks pretty good across. When I compare it to the template, it lines up exactly. And these are big dovetails too, so see the accuracy of the setup. And that's the beauty of the threaded rod. The threaded rod actually holds it in place, even though my threaded rod just popped out. That's the problem with the hot melt glue. It won't hold it forever. So, but it didn't seem to mess up the accuracy of this, which looks really good. All right, it's a couple days later, and I got another thing to talk about. I had a comment recently, and I apologize because I can't find it anymore. I've gotten so many comments over the last few videos, and the comment section on YouTube is such a mess that it's crazy. I've almost given up on the comments, actually. Anyway, I got a comment about the best way to join MDF, two pieces of MDF together. MDF is a good material for certain things, but it's not known for its strength, and its main weakness is how it's layered. It's almost made like a pie crust, and you know how flaky a pie crust is. And what happens when you glue two pieces together like this, I've got done here, is the glue adheres to the surface layer only. It doesn't penetrate in. And the surface layer is just attached to what's underneath by the same kind of not very good glue that holds the rest of it together. So you wind up with something that's very weak. I've got this one glued together with epoxy, mainly so that I could get it done quickly to show you how it works. But if you were to use wood glue, it'd be the same deal. That glue only sticks to that surface layer, and that surface layer will break off quite easily. All right, I have my sample here, and I'm gonna break it. Now, if I had two pieces of wood, say solid wood, with the grain going this way, across like that, and they were glued together like that, that would be very strong. It'd be very difficult to break that joint. I'm just gonna put it here in my vise, and I don't think it's gonna take any more than just like a tap with my chisel here to break that. And you can see it comes apart, and here's what you have. You have the entire subsurface of the MDF has released and stayed on the other piece over here. So that's the weakness of MDF. And the best way to join these is to have something that goes through all of those layers on the other piece and goes into this one. But that causes another problem, because MDF, because it's layered like that, will split easily as well. So I think that the absolute ideal way to join two pieces of MDF that are butt joined like this is to glue them together first, clamp it up really well. Don't put any pressure on it until you have a chance to drive dowels through. You can drill holes and put dowels, glue dowels in, and then the dowels will bridge all this material on one side and go into the other side. The beauty of the dowel is that it won't put any stress on the other piece of material to make it swell out and split. Whereas if you were to drive screws in, you could drive screws in, but you'd have to be very careful with the pilot hole that you drill. You'll want to actually drill the pilot hole slightly oversized, and then to make it stronger, put some glue in there, like epoxy or construction adhesive, or even regular wood glue squeezed into the hole, so that the screw will actually attach to that as it goes in, and that will make the joint a lot stronger. I've got one other thing that I want to talk about before I go, and that's, I recently commented on the heating in my shop. I said that the shop is heated just to 5 degrees in the winter, and I can't afford to heat it any warmer than that. Actually, I find that this temperature, the 5 degrees, it's not actually 5 degrees. That's what it says on that thermostat over there. I think the actual temperature in here most days is around 7 or 8 or 9 or maybe even 10 degrees. Depends upon the temperature outdoors. And that's Celsius, that's not Fahrenheit. Those would be, somewhere around 40 to 50 degrees Fahrenheit. I find that comfortable to work in for the most part. I can wear my sweatshirt here, no problem. If I need to make a cut on the table saw and roll up my sleeves, no problem. It's not bitter cold in here. And one of the reasons for that is because of the way I have this shop insulated. I didn't insulate this floor slab here. There's a big concrete slab here, as you can see. And a lot of people, the first thing that they do when they get a garage and they want to change it into a workshop is they build up the floor and they put insulation in there and they have wood on there, and they think that they're saving a lot of money by doing that. But what they're actually doing is they're taking away a really good temperature regulator for the shop, and it's this giant piece of concrete right here. Now in the summertime, this wants to stay the same temperature because the outside of the shop is insulated to the point where it doesn't allow that much heat in. So in the summertime, it never gets very hot in here at all. I think the most it ever got in here in the past 2 years since I finished insulating the outside is around 25 degrees Celsius. And I'll put on the screen what that is in Fahrenheit because I'm a little slow on the math today. But that's really good because we've had days where it's hit almost 40 degrees Celsius in the summer. And if you can keep it to 25 degrees in here, that's really good. Okay, what I've got here and what the Focus Master is stepping on is a thermocouple for my multimeter, and that'll tell the temperature of this floor slab. I'm going to turn it on to Celsius first. And I'm getting a reading of 9 degrees. I don't know if you can see that on the camera, but you can take my word for it. It's 9 degrees Celsius. When I switch it to Fahrenheit, that's 49 degrees or 48 degrees Fahrenheit. Now, if I take it off the floor and just measure the air temperature, it's not changing. The air temperature in here is still 49 degrees. It matches the floor slab. And that's the case pretty much year round. This floor slab is insulated around the outside. I added insulation to the outside of the shop on the walls, first of all, and then I insulated the bottom of the edge of the slab where it meets the cold outdoors. So what you have underneath here is ground that never gets cold and it never gets hot. It stays at that constant temperature. And it's a temperature that my 2,000 watt heater over there can easily reach. So yeah, if you're in a country that gets cold winters and fairly hot summers, this would be the way to build your shop if you're going to start from scratch. Or if you're going to start with a building that already exists, don't waste your money on building up a floor and insulating the floor. You're not going to lose any heat out through that actually. Take that money and spend it on insulating the walls and the ceiling as much as you can.